Okay, that was strategically planned. Actually, it wasn't at all, but I was going to say it was strategically planned thinking time for you to get this. Some of you use that as daydreaming time, but you're not going to understand it if you don't think about it here. It takes some time to think about it. If you don't include all the objects, it's not as simple as just saying it's just that times all the numbers below it, right? Because you're not including some of the objects. If you were including all 5 of the objects, it would just be this, 5 times 4 times 3 times 2 times 1. If we're not including one, for every one we don't include, it's left off. We don't multiply by that number, right? You're just left with the ones that you are including. That's fine when we have a low number like this, but if we were choosing this out of a really large number, sometimes it's easier to get it using factorials. We're going to write a formula for permutations using factorials, and the way we have to get it is indirectly here. The way you're going to get it is by saying, I'm going to pretend I was including all of them, 5 factorial. What would that give me? What number is that on top? It's 5 times 4 times 3 times 2 times 1. What was that number? 120. On the bottom, I'm dividing by all the arrangements of the ones I'm not including. 3 times 2 times 1. Or in other words, that's 6. That's how you get your 20. You get it indirectly by counting arrangements of all of them. Arrangements of all. And then the bottom is the arrangements of the ones you're not picking. Of ones not chosen. The premise though, okay? The formula for figuring out the number of permutations of objects. If you have all 7, like this, so this is 7 letters here just to change it up a bit. If you are choosing all 7 of them, it's just 7 factorial. Or in other words, 7 times 6 times 5 times 4 times 3 times 2 times 1, whatever that number is. Somebody can figure that out after. It's just 7 factorial. If you have less than that, if you're choosing less than all of them, if you're only choosing 3 of those letters, you could just use the fundamental counting principle and say, well, if I'm choosing 3 of them, it's going to be what? It's going to be 7 times 6 times 5. You can get it indirectly because we want to be able to write a formula that always works. This we have to think about every single time, not that it's hard, but it's going to be different numbers of different amounts of numbers you're multiplying. The way we are going to get it indirectly is by saying, I am going to count all of them. That's how many arrangements of all of them. But I'm going to divide by the ones over here that we're not choosing. How many of them are there that you're not choosing? 4. And how many arrangements are there for those 4 you're not choosing? 4 factorial, right? This is the formula that you're going to use. That's the expression to get how many there are here. It's just going to be 7 times 6 times 5. I understand that. So please don't say, I don't need this stupid thing you're teaching us because I'm just going to do it this way. You need to understand both, okay, for the development of other ideas here. This is the arrangements of all of them. This is the ones not chosen. All right. What does that number give you? Let's pause. On your calculator, on this calculator or lots of different calculators, there will be a feature on there somewhere, this factorial. On this calculator, it happens to be under math, over to probability, down to there. That's where the factorial, it's pretty hidden on here. I don't know, sometimes you have to find it on your particular calculator. If you're using it here, okay, just like the ones we know here, 5 factorial, it should be 120, right? Here I need to find 7 times 6 times 5. I realize that that's not many numbers, and for this one it's quicker to just multiply those 3 numbers, than to go and put that expression in. But if there was quite a difference between those numbers, you don't want to go 70 times 69, 68, 67, 66. It's easier to get it with factorials. Okay? That's part of the rationale for this here. You get that same thing. This should work out to 210 here. If you do 7, you go to find the factorial thing. 7 factorial divided by 4 factorial. You get that. You get 210. Right? This should be 210. You can get it using your calculator, or you can expand it by hand. This one's not that hard to expand by hand here. And you do have to know how to work with factorial expressions. How could I calculate this just the long way here without writing everything out all the way down to 1? I realize you could write it all the way down to 1 and write this divided by 4 times 3 times 2 times 1. But you don't need to write them all out down to the bottom, because 7 times 6 times 5 times 4 times 3 times 2 times 1 over 4 times 3 times 2 times 1. Did I really have to write them both all the way down to the bottom? No, where could I have stopped? Yeah, you could have stopped at, I could have stopped at 5 and then written 4 factorial. All of this is going to cancel, right? That cancels out. What I could have written is 7 times 6 times 5 times 4 factorial divided by 4 factorial. And I could have done this, right? That and that divide, and then you're just left with that. You need to be able to work with the expressions both ways. All right? We already talked about factorial notation. That's factorial notation. You already know 4 factorial is 4 times 3 times 2 times 1 if you want it there. 3 times 2 times 1. 2 times 1. What's 1 factorial? 1. What's 0 factorial? It's actually 1. If you think about it in terms of number of ways to arrange objects, if I say here's 2 objects, that and this, there's your 2 objects. How many ways can I arrange those 2 objects? 2 factorial, right? Because I could do that, or I could move that one over there. If I only have 1 object, how many ways are there to arrange that 1 object? 1 way, 1 factorial. This one's tough. What if there are no objects? How many ways can you arrange no objects? 1 way. There it is, right? Anyways. The formula for permutations. We have already developed with numbers. We just haven't done it with variables. I want you to think about the one we had up above there. When we were choosing 3 objects from 7, where order matters, we're talking about permutations. Later we're going to have things like choosing 3 from 7 where we don't care about the order. That's going to be called combinations, not permutations. The shorthand for this is NPR. In other words here, 7P3. This is a shorthand. Again, mathematicians are lazy, right? They like to write with symbols. 7P3 means exactly this, right? This means this. This is good when you highlight everything. It really draws attention to nothing. I guess we could highlight just the important stuff here. This whole thing means this. That's the same, okay? 7P3 means choosing 3 from 7 where the order matters. For combinations, I'll just give you a preview, foreshadowing. What letter is it going to be? It's not going to be a P for permutations. It's going to be a C. Capital C. If we choose 3 from 7 where we don't care about the order, then you're going to do that. Okay? The order matters here. The formula, what did we have in terms of factorials for this one? What was our expression? It was something divided by something. What was it here? What was on top? Arrangements of all of the objects, 7 factorial. Divided by 4 factorial. Notice that the 4 doesn't come from this. It's neither of those numbers. Where does the 4 come from? 7 minus 3. and this is 7, of course. If we're using these, what's the formula going to look like here? It's going to be on top. This is black. What's on top of it? What's the top number? It's n factorial. That's the number of objects. What goes on the bottom? N minus r, factorial. That's the formula for number of permutations. This is on your formula sheet, if you care. I will give you this for tests and stuff because I figured that would be the next question here. But you have to understand it. This is the arrangements of all the objects. This bottom thing is the arrangements of the ones you do not choose.